I got some caffeine over there if you need it.
Okay, I do.
All right. Well, go ahead.
Inverse matrices.
Inverse matrices. This sounds like a wonderful intro to me. So now, if we have a matrix A, and I got really creative, and I labeled it A, B, C, D, and we want to find its inverse. Now, the inverse is denoted this way. A with the little superscript -1 on top of it. So that means A inverse. So a couple of things have to happen when you are finding the inverse. The first step is to take 1 and divide it by A times D. So that's A times D minus B times C. So minus B times C. Man, that looks familiar. A times D, B times C. What is that?
Is that the determinant?
Yes, I'm determined it's the determinant. All right, you like that, didn't you?
It's like
all right, can you kind of walk me through where on earth does that part come from?
So there is a pattern here. If I look at this D and A, if you notice, that's actually just switching the positions of A and D, right? You just
so those just trade, all right?
Now B and C, B doesn't actually go anywhere and C doesn't go anywhere, but their signs change. All right, so this doesn't mean that they're always negative.
Correct. So if B had been a negative number, now it would be a positive.
Right.
The signs change.
Okay.
Okay. So this would be worth pausing right now and writing down.
Yeah.
Well, actually,
Highlighting.
probably the whole thing, right?
Yeah.
A inverse. All right. Is that what you wanted?
I wanted stars, yeah.
All right. I'm happy there too. So let's actually use it. We want to say, here's matrix A, and we want to find the inverse of matrix A. So the inverse is going to be 1 divided by, I remember it was A times D, so 2 times 4 is 8, minus -3 times 4 is -12. And then multiplied that by, oh my goodness, I'm going to run out of room, aren't I? All right, sorry about that.
Sorry, we'll work
So
it out.
you said A and D trade places. So my A and my D are going to trade places. So we're going to have a 4, we're going to have a 2. And then these two change signs. So -3 changes to +3, and 4 changes to -4. What is 8 minus -12 there?
It's 20.
Chris?
20.
All right, 20. So really, that's 20 on
You're
the
really
bottom.
good with the colors. You're on the
I know.
ball
I
tonight.
failed coloring in elementary school, but now I can do it. I don't know what it is. You should see me with spray paint. All right. So I would say this is a pretty good answer, wouldn't you, sir?
That's beautiful.
I've seen the matrix written that way, or the inverse written
I
that
think
way
that's
before.
fun.
I have also seen it where they take the 1/20 and multiply it by all 4 terms.
Right, because it's just a scalar. So.
Right. If we were going to do that, then the inverse matrix would equal, let's see, we'll go, A inverse is going to be, what's 4/20?
1 over 5.
1/5. You could use a decimal there too, I would
Sure.
think. That's not a problem. What's 3/20? Well, that's 3/20. -4/20 is -1/5. And then 2/20 is 1/10. So I would say either one of these are really good answers. Agreed?
Yep.
Okay, let's try a tricky one. Check this one out. So we're going to start with the inverse is going to be 1 divided by 4 times 4 is 16, minus 4 times 4 is 16. Oh, the insanity!
Yeah, if you divide by 0, you create a small tear in the universe. You don't want to be responsible for that, so we don't do it.
So really there is no inverse here. Agreed?
I agree.
No inverse. All right, very, very cool. So you can run into that where there's no inverse.
Yeah,
And
absolutely.
we run into where there is an inverse, but you got to kind of work it out. Okay, there are certain things we need to go back and look at before we do verifying inverses. We need to look at what does it mean for something to be an identity.
Yeah.
So to be an identity, there we've learned back in probably elementary school.
Yeah, it's one of those things that you learn and then kind of forget.
Right.
Yeah.
The multiplicative identity, I think, was 1.
Right.
Because anything times 1 gives itself back. Anything times 1 returns itself.
Right.
All right, so that's the multiplicative identity. Do you remember the additive identity?
Yeah, I think the additive identity was 0, right?
Yeah, because if we took like
0,
6 plus 0, we'd get
6.
6 back. You get the
Change.
thing back.
Right.
If we took A plus 0, you'd get A back.
Yeah.
So there must be some type of identity for matrices. And we have a guest speaker with us today to talk about the identity
Kaufman.
matrix. Ms. Kaufman from Elmo College is here to talk about identity matrices.
Okay, so like Mr. Cresswell and Mr. Kelly already talked about, there is an identity matrix for matrices. Now this is what we call the identity matrix, which means anything times this matrix will spit out the same thing, like they said before with multiplication and addition. So if we take this matrix times 3, 4, 3, 4, we're going to get the same matrix back. 3, 4, 3, 4. And it's as simple as that.
Are we happy?
I think so.
All right, very cool, very cool.
Thank you.
So thank you so much for coming in and helping us out today. We were in a fight over that one. Okay, Mr. Creswell, would you verify that these two are inverses of each other?
We've got to do 2 things to verify that matrix A and A inverses are actually inverses. We've got to take A times A inverse, and that's got to give me the identity. Are we okay with just calling it big I?
I for identity.
I
yeah,
for
I can
identity.
do that
Okay.
one.
And then we've got to check the other way, A inverse times A, and make sure that's the identity. Because it's possible that multiplication of matrices is not commutative.
Yes,
All right,
very
so
good.
Let's clear this out of here. All right, so let's do it. A times A inverse. So I've got 3, 1, 4, 2 times 1, negative 0.5. Oh. Negative 2 and 1.5. Make sure that's not 21 or 21.5. That's negative 2 and 1.5.
Okay, you ready?
Multiply. Let's do it.
You ready? All
All
right.
right. Top row times.
So 3 times 1, 1 times negative 2. 3 times 1 is 3, plus negative 2 is
1.
1.
Okay.
All right, fantastic.
Okay.
And now we'll go here and here, correct?
Right.
3 times negative 1/2 is negative 1.5,
Yeah.
plus 1.5.
0?
0. Oh, that's looking good
Oh,
so
good,
far.
excellent, yeah.
All right, and now we'll go across this way. 4 times 2 and 1 times negative 2. So we have 4 plus negative 4.
0.
Yay, I'm happy.
There you go.
Oh, this is getting really ugly. Help, help, help. Am I here and here?
Yep.
All right, so 4 times negative 0.5 is negative 2. Is that right?
Yep.
Plus 2 times 1.5 is 3. Negative 2 plus 3?
1.
Well, hot dog, look at that. All right, there's the identity.
Good, we win. Let's
And,
try it the other way.
Okay,
now.
you want me? I will
Here we
write,
go.
and you can do it.
Okay,
How's that?
1,
One.
negative 0.5,
Yep,
negative 2,
Yep.
1.5. Okay, multiply that by 3, 1, 4, 2.
Okay, and I'm gonna multiply. Oh my goodness, look at that! It came
It
out.
worked.
Oh, the insanity! Wouldn't it be nice if we had some technology to multiply matrices?
Yeah, that'd be great.
Man, someday. All right, thanks for taking our